Good day, grade 10s. In this set of lessons, we're going to learn about states of matter and the kinetic molecular theory. First, let's learn about the three states of matter, also called phases. There are three states of matter which we know about. They are solids, liquids, and gases. Admittedly, some of you may have heard of a fourth one called plasma, but that is not in your grade 10 curriculum, so we're not going to be covering that now. The structure, arrangement and movement of the particles determines the state of the substance. In other words, it determines whether it is a solid, a liquid, or a gas. So let's have a look at this. Here we have three beakers. We've got a gas, a liquid, and a solid. In the first beaker, you can see the gas. The particles are moving around. They've got high energy. There's large spaces between them. And if we try and pour it out, you will see it doesn't really pour. Some of the particles leave, some of them don't. It kind of bounces out if it wants to. Liquid particles, on the other hand, have got a lot less energy. The particles are closer together, but they're still moving. And if we try and pour it out, you'll notice it kind of takes the shape of the container, and there you go. You can beautifully pour it out, as we know. Solids are very tightly packed. The particles vibrate where they stand, and as you know with solids, you can't pour them. Right, so now let us summarize this in a table. We can see that we've got solids which have got a very low energy, and that means that the particles vibrate around a fixed point. Liquid particles have got more energy than solids, and therefore they move more freely, whereas gas particles have got high energy and they're constantly moving. Because of this, the gas particles have large spaces of high energy, whereas because of the high energy, the liquids have got large spaces between the particles, but they are smaller than the gases, and they are much bigger than the solids. Solids have got very little space between the particles, and the particles are very tightly packed. And all of this is because the solids have got very strong forces of attraction between the particles, whereas the liquids have got weaker forces of attraction, and the gases have got the very weakest forces of attraction. So from this we know that your gases will fill the entire container, liquids can be poured and take the shape of the container, whereas solids have a fixed volume and cannot really be poured. Now the Brownian motion is the random movement of microscopic particles suspended in a liquid or a gas, and it's caused by the collisions with molecules of the surrounding medium. So if we look at a little demo, we can see here that we've got one big atom or molecule, and we've got hundreds of little atoms or molecules, and they're all bouncing into it and into each other in all different directions. So basically that is what Brownian motion is, and you can see from this diagram that they're trying to indicate that we do not know in which direction these particles are going to go. That's why they call it the random movement. And please note that this is only in liquids and gases. Now diffusion. Diffusion is the movement of particles from a region of high concentration to lower concentration, and it leads to the even distribution of particles throughout the gas and liquid. So let's look at a little bit of diffusion. Here the person has put some blue ink in the water, and you will see slowly that the blue ink disperses in the water so that eventually it will take up all of the water. It'll be all the same color eventually. Now what we could also do, here we go, is we could change the temperature, and you will note that in the hot water the dispersion or diffusion occurs much faster than the cold water, and that is because in the hot water the particles have got a lot more energy, and when they have a lot more energy they tend to bounce much faster and interact and spread out. Now let's look at a diffusion of gases. What we've got here is one cotton wool which is filled with one type of gas, and we've got another cotton wool that is filled with another type of gas. Now what's going to happen when these two meet, they're going to have a reaction and they're going to form something. So there we go, we've got ammonia and HCl, hydrogen chloride, which are bigger, and here they're forming this white ammonium chloride. So here you can actually see an animation, admittedly, but in real life what you would see is a white gas being formed in the middle here. You wouldn't see the little particles here, you wouldn't see these, but you would see a white gas being formed, and that would be the ammonium chloride. Thank you, grade 10s. I hope that you found this useful.